Okay, so I am going to share my screen in the Google Meet. So just make sure that you can see that. I'm going to go over those 5 questions from yesterday. Some of you were confused on that last one where you had to write your own problem. So I will go over that. I'm going to share out some of the classmates' answers. Some of you wrote really good stuff. So take a look in your Google Meet. You should see my screen. Question number 1, a lot of us recognize that, yes, that was a proportional relationship, but some of you just said yes. Some of you just said the number 5, and I want you to pay attention to how this student wrote the answer. Yes, this is proportional because each portrait takes 5 hours. That's the kind of language we want to use when we're talking about constant of proportionality. How many does the right side increase by? A lot of you noticed 5, but you also want to include that your left side's increasing by 1. So you can word it just like this. Each portrait takes 5 hours. You can say 5 hours per portrait, but you want to make sure you're using that unit. Whenever the direction said, don't forget your units, that's what you wanted your answer to look like. Number 2, we again found that it was proportional. A lot of us said yes, a lot of us said 4. So if you got that answer right, I just want you to work on today, making sure you're using those units when you're explaining it. Each cup of ice cream is $4 or $4 per cup. You want to use that type of wording. Number 3 was a little bit tricky. A lot of you noticed right off the bat that it might have been proportional because 8 times 2 is 16, 9 times 2 is 18, 10 times 2 is 20. And then you decided your answer. However, if you look at this bottom row, 11 times 2 does not give you 23. So anytime you find only one answer in that table that doesn't match up and doesn't follow your pattern, you're not allowed to say that it is proportional. Just like she said, all numbers are multiplied by 2 to get time except 11. 11 times 2 gives you 22, not 23. So you just had to be careful there. Same thing happened in question 4. So we noticed 2 times 3 is 6, 4 times 3 is 12, 8 times 3 is 24. However, if you notice this answer in here in my third row, 6 times 3 does not give me 16. So that one was not proportional either because that row did not follow your pattern. So you have to make sure you're testing all of those rows. Even though 3 of them worked, anytime you have one that doesn't fit the pattern, you have to throw it out. And then number 5, you guys did really well. A lot of you recognized what we were talking about yesterday with paying attention to writing your constant of proportionality as a fraction. So 5 divided by 10, 6 divided by 12, 7 by 14 gives you a constant of proportionality of 1/2. So remember, we want to kind of stay away from saying that it's 2 because I'm not multiplying 10 times 2 to get 5. I'm multiplying it by 1/2. So if you notice that you're doing that work of dividing by a number, you're going to say that that constant of proportionality is a fraction. But overall, you guys did really well on that. Just try to today, as we go through some of these problems, pay attention to how you're writing your units. Some of you were confused on this last question. You just needed to create your own scenario and use 3 pairs of numbers. So you can see this student did 6 times 4 is 24, 8 times 4 is 32, 10 times 4 is 40. That's great. A lot of you did that same type of thing. When it said create your own scenario, I was kind of looking for more of a word type problem. So take a look at what this student said. Oops, I don't know why that showed up. Creating trail mix to take to her volleyball game. She wanted to make some for her teammates as well. She gave herself 1 cup pretzels to 2 cups Chex Mix. So her ratio is 1 to 2. So then she came up with a couple other sets. 3 cups of pretzels to 6 cups of Chex Mix. Her coach wanted some too, so she did a 1/2 cup to 1. So that's all I was looking for there, some kind of word problem similar to what you were looking for. But like I said, some of you just picked out numbers that matched a pattern, all good and perfectly fine. So again, if you notice that you got the answers right in here and you didn't write your units, that's going to be your goal today, is to make sure that you're using that right type of language. How the right changes for 1 unit change in the left. So this would be trips per bike or miles per hour and things like that. Okay, now we can go into the Nearpod. I'm going to push the screen to give you to your first question. We're going to go through just a handful of different table problems like we've been working with. You're going to fill in the table, and then I also want you on each problem we do to write out what your constant of proportionality is. So that would be just like we did in that Google form homework, find that number, but when you're writing your constant of proportionality, make sure you have those units attached. So if you're in the Nearpod, you should see your first screen. You have a proportional relationship between any length measured in centimeters and the same length measured in millimeters. So you're given that diagram there. Use that picture to help you find the pattern to fill in the rest of the table. So if I have 9 centimeters, how many millimeters is that going to be? If I have 12.5, 50, and then 88.49, how many millimeters am I going to have? And then once you fill in your table, define and write out what your constant of proportionality will be. Again, trying to pay particular attention to the units. It's very important that when we write the constant of proportionality, you're including that unit. So if you filled in that table, I also want you to write, I know it's hard to see question B with that toolbar anywhere on that paper. Question B is asking you, what is the constant of proportionality? So write that answer and then make sure you have your label in it also, or your unit. It's all good, Heather. Just we're in the Nearpod, so you can follow the link in Google Classroom. I will send it through here. We actually just started on the Nearpod. I just spent some time going over yesterday's homework. And again, as you're answering that question, what is the constant of proportionality? I'm very confident we're all going to see this problem and know what number it is, but try to figure out what units you would have attached. When we talk about the units for constant of proportionality, it's things like miles per hour, clicks per second, dollars per hour if we're talking about working. So in this problem where we're comparing centimeters to millimeters, and we filled in that table, what number helped us get from left to right, and then what would the unit be attached to it? And we don't want to just say the number. All right, so I will share out the answer. You guys are doing really good things. I'm going to share this one because I like what this student did on the picture. So she noticed that from centimeters to millimeters, I was multiplying by 10. Again, that's that same work that we were talking about. I can find my constant of proportionality by taking the right side of my table, which is millimeters, divided by the left side, which is centimeters. So 10 millimeters divided by 1 is 10. But we can see that just by looking at it. So then I took that constant of proportionality and multiplied everything in that table by 10. But we want to be careful here because I see a lot of you doing this same thing. Question B is correct. Constant of proportionality is 10, but we want to emphasize what the unit is. So we don't want to just say 10. You always want to use your unit and it's right to left. So what I mean by that is that when we're explaining what that constant is, we want to make sure that we're saying 10 millimeters per centimeter. It's always the right side for one change in the left side. So I have 10 millimeters per centimeter. So keep that in mind as I work through the next one, or as you work through the next one. This time we have the same diagram, but pay attention to what it's asking. Now it says if we know the length of something in millimeters, we can calculate its length in centimeters. So we're doing the reverse or the flip-flop. So if I have 70 millimeters, how many centimeters is that going to be? 245, 4, and 699.1. So calculate how many centimeters you're going to have. And then write your constant of proportionality and be very careful. Think about what we were talking about yesterday. Write your constant of proportionality and make sure you have your unit attached. Because I see we're all getting the hang of finding the patterns in the table and using the numbers, which is great. Now I just want us to practice making sure we understand what's happening whenever we have these kinds of tables where we're decreasing. And this is very similar to the other one, but we're going to notice that when we're doing table problems like this and constants of proportionality, proportional relationships, we have to pay particular attention to the language that the question is using. I'm going from centimeters to millimeters. So what does that mean mathematically that we have to do? See us all with good tables. I see us all finding the constant of proportionality, but keep in mind, I am going to push us to try and make sure we're not saying divide by a number. So if you're writing that answer as dividing by 10, think about what that means we're actually multiplying by. Think about what we talked about yesterday. If you're doing that math of dividing by right to left, what does that mean your constant of proportionality is? Because when we're talking about proportional relationships, it's always multiplication. So if you're dividing by 10, like some of you are writing, what does that mean you would be multiplying by? Think about that for a second and give you guys a second more to finish up writing. I'm going to share out the answer. Okay, if you feel like you're done, make sure you hit submit. Can't share it out. I see some answers that I like that I would want to share out. I'm just waiting for them to get submitted. Okay, so a lot of us noticed what that pattern was. So if I'm going from millimeters now back to centimeters, we're dividing by 10. So a lot of us recognize that. Millimeters down to centimeters, 10 to 1, 20 to 2, 30 to 3, we're dividing by 10. So we followed that pattern and divided everything in the left by 10 to get my answers in the right. And then some of you are going in and saying that my constant of proportionality is to divide by 10, which is correct. But I also want us to recognize that that does not mean that my constant of proportionality is 10. Even though the math that we're doing is dividing by 10, we want to make sure that we're using that fraction like we looked at yesterday. And again, if these fraction ones confuse you, the ones where we're decreasing, always just take the unit on the right divided by the unit on the left. So I can take any number of centimeters, divide by any number of millimeters. So that's what I did over here on the right. 1 divided by 10, that's my constant of proportionality. Not 10, it's 1/10. And then my unit would be centimeters per millimeter because that's the right to the left. It's always how the right changes for 1 unit change in the left. Again, a lot of you are noticing that it's dividing by 10, which is good, but you just have to be careful that that means your constant of proportionality is 1/10. There's a difference there. All right, take a look at the next slide. Now it says that your constant of proportionality of centimeters to millimeters is 10, and the constant of proportionality from millimeters to centimeters is 1/10. So we can see this relationship of going one direction and then backwards. So think about question 3. How are they related to each other? You can feel free to type your answer in. It might be, I know, kind of hard to write it out with your pen. So how are they related? What do you notice about them? And then try to fill in those blanks. Convert centimeters to millimeters. What can we multiply by? And if I'm going millimeters to centimeters, we can divide or multiply by what? So what do you notice about those two constants of proportionality? And then fill in those blanks. Be careful for part B. I see us using the same number to fill in those blanks. You cannot multiply by 10 and divide by 10. That's not going to give you the same thing. So if you're writing that in, think about what we just talked about. If I'm converting from millimeters to centimeters, I can divide by something, or that means I'm multiplying by something else. But dividing by 10 and multiplying by 10 does not give you the same thing. So what you should notice for question 3, I'm just going to talk about this as you're finishing up. Whenever we have numbers like that, 10 and 1/10, we call them reciprocals. Okay, you might have heard that last year in 6th grade. That just means your fractions are flipped upside down. 3/4 and 4/3, 5/6, 6/5. Anytime your fractions are flipped like that, it's a reciprocal. And you're going to notice that happens if we're doing proportional relationships and we're going back and forth in a table. So from one side to the other, I can multiply by 10. That means to go backwards, and from that back to where I started, I can take that reciprocal and multiply it by 1/10. So if my constant going one way is 3/4, that means my constant going the other way is 4/3. Okay, so it's a process of just flipping it upside down. So to fill in your blanks, you should notice that to go from centimeters to millimeters, you're multiplying by 10. And then for question B, if I'm going the other way, I can divide by 10, right? If I'm going backwards from multiplication, I can divide by 10, or dividing by 10 and multiplying by 1/10 is the same, okay? Again, so you can see that. Here's what one student said. I can divide by 10 or multiply by 0.10. That's exactly correct. 0.10 is the same as that fraction, but that's what we're trying to understand here. If I'm dividing by 10, it's the same thing as multiplying by that fraction or that decimal that's associated with it. Here's another table. This one is a little bit more difficult because there's fractions in it. So my sentence starting out the problem gives me the key piece of information that I need. It says Noah is running a portion of a marathon at a constant speed of 6 miles per hour. Complete the table. So that first sentence helps me figure out the first row. In 1 hour, how far am I going to run? So then try and go through and fill out the rest. There are a lot of fractions here. The fractions are throwing you off. Always remember that you can convert them to a decimal. 1/2 is 0.5. 1 1/3 would be 1.3, repeating all the way down. So if the fractions are throwing you off, convert them to decimals, and then just go through it exactly like we've been doing. That sentence gives you the constant of proportionality. Use that to fill in the rest. Again, if the fractions are throwing you off, make them a decimal and then do it exactly the same way. If you need help with the decimals, you can ask in the Google Meet. Oh, sorry, Sada, you just sent it. Yeah, that's fine. If you need help with the fractions, you can speak up in the Google Meet. You can type it in. But just remember, it's top number divided by bottom number. And if you have that whole number out front, just keep it outside of your decimal. 1 1/3 would be 1.3 repeating. 1 1/2 is 1.5. Fractions are no different. Convert it to a decimal. Use the same rules that we just did. This problem's also a little bit different because I have some blanks open on the right and some blanks on the left. So you're going to think about what that means with what you have to do with that number. How do I go from left to right? How do I go from right to left? Perfect. I see some of you keeping your answers as fractions in the table. Like I said the other day, I am really, really impressed with how well you guys handle and work with fractions, especially being on your own with me not forcing you to do it. So if it's 1 and 1/2, Heather, you would keep the 1, so it'd be 1 point, and then just convert that 1/2. So do 1 divided by 2. So it'd be 1 point, and then 1 divided by 2, whatever decimal you get there. Take another minute to finish up. I'm going to share out the answer. We seem to be split down the middle here. We're good with the first 2 rows because we can see the pattern there, not even constant of proportionality. You might be able to use scale factors there, which I see a lot of us doing. And then we're hitting a rut when we get to those bottom 3 rows, which is all right. Some of you are writing me messages, so I will share out the answer. I'll share it out in Nearpod and the Google Meet. That way I can point around with my mouse as I'm talking. But go ahead and take a look at the screen. Let me share in the Google Meet because it is confusing. There's a lot going on, and those fractions make things seem a lot more confusing to us than they need to be. So again, that first sentence tells us that we're going 6 miles per hour. That's my constant of proportionality. That tells me that I can take everything in the left and multiply it by 6, and it will give me everything in the right, which is great whenever I have 1, because I can easily do 1 times 6. So then I would just do 1/2 times 6. And remember that if I'm multiplying by a fraction, it just means I'm dividing. So 1/2 times 6 is equal to 3. I don't know what is going on here. That doesn't make any sense. But 1/2 times 6 is 3. Or you might have noticed that I cut 1 in half, so I can also cut 6 in half. 1 1/3, if you look over here, I converted that into a decimal, which is fine. 1.3 repeating, and then times my constant of proportionality gives me 8. Up here, you can see I just worked with my fractions. So if you're good with fractions, you can see what I did up there. I converted it to an improper. 3 times 1 plus 1. Then I multiplied by 6, multiply straight into the top. But again, if you're stuck with the fractions, don't even pay attention to what's going on there. Keep in mind that you can just make it a decimal. 1 1/3 is 1.3 repeating. Once I know that, multiply it by my constant of proportionality, and I get 8. Then we're stuck with these bottom rows where I'm given the number of miles and I need to find the hours. So if I'm multiplying by 6 to go left to right, and I'm going backwards, I can divide by 6. So anytime you're moving backwards in the table, you're doing the opposite of multiplication, which is always going to be division. So then I did 1 1/2 divide by 6. And again, I'm confused with the fraction, so I made it into a decimal. So then I can just type 1.5 divided by 6 into my calculator, and I get 1/4. Did the same thing here. 9 divided by 6 gave me 1.5, or 3/2. And then 4 1/2, I made that into a decimal. 4.5 divided by 6 gave me 0.75. So you can see I did a lot of work going back and forth between fractions and decimals. So stick with whatever's easiest for you. Some of you, like I keep saying, I'm really impressed with you keeping your fractions like this. But if you want to, you can write all of your answers in decimals like I did here. Main thing you want to pick out of this problem is that if I'm going from the left to the right, you're multiplying. You're using your constant of proportionality to multiply through. But if you're going backwards to where you started, to move backwards in multiplication means you're dividing. So I'm taking that same constant of proportionality and dividing everything by 6. If you're confused on the fractions, that is perfectly okay. You're not going to see too many fraction problems, but we're going to throw them in every once in a while. But that's not the main goal here. The main point is to realize how to move back and forth in the table. So you're multiplying by 6 and you're dividing by 6. So if you understand then you're good with a question like this. Don't get too hard on yourself because of the fractions. Here is our last table problem. So we're given two different tables, but you can see we're kind of comparing the same thing. Stop presenting because I have the answer up there. In table A, I have meters on the left to kilometers on the right. So find your constant of proportionality, fill in the table. And then on the left, I have kilometers to meters. So again, you can see we're comparing the same thing, but we're just going in different directions. For table A, I'm getting smaller. Table B, I'm getting bigger. So fill in those tables and then try and think about what your constant of proportionality would be. It's not going to be the same for both tables. When you're answering those bottom questions, constant of proportionality tells us, think about what we've been talking about. Think about the centimeters to millimeters. I had 10 and 1/10. So think about what that might mean here for this problem. And be careful with our math. I see some of us doing the right thing, but you're leaving out some zeros in your work. So some of you are working as if it were 100, not 1,000. So some of you are just missing some place values in your answers. Okay, and if you fill in that table, make sure you're taking a look at those bottom questions. What is the constant of proportionality in each table? What are you doing from left to right in A? What are you doing from left to right in B? And then I'm also going to push you that if you're using the language of dividing, perfectly fine if that's the math that you're doing, but also try and think about what that means your constant is. So if you're dividing by a number, what's your constant of proportionality? Okay, take a minute to finish up whatever you're writing. I'll share this answer out. Our next slide is just going to be a collaborate slide where there's going to be a question that you're all going to answer, and then I will explain what you're looking into for the rest of the day. Okay, so if you're still working, that is perfectly fine. Take a look. You guys all filled your tables in really well. You notice that in table A, we're dividing by 1,000 to go from meters to kilometers. So everything in the left, divide by 1,000. And then we notice that everything on table B, you multiplied by 1,000. So you can see this student wrote those patterns down below. That is perfectly correct, but I am going to push you. I noticed a lot of you saying that same thing where you're dividing by 1,000. So we really want to pay attention to what that means our constant of proportionality is. On table B, if I multiply by 1,000, my constant of proportionality is 1,000. So I have to figure out what am I actually multiplying by in A. If I'm dividing by 1,000, what does that mean we're multiplying by? So take a look. The student did the same thing. Patterns are exactly the same, but we're noticing here that for my pattern in A, I'm taking meters times 1/1,000. So that fraction work there is the same thing that you guys are saying where you're dividing by 1,000, but you have to pay attention to the fact that that is what your constant of proportionality is. If I'm dividing by 1,000, it means I'm multiplying those meters by 1/1,000 to get kilometers. And then on the right, it means I'm taking kilometers times 1,000. Perfect. Here's our last question. It says that there are 12 inches in 1 foot. Jada says that the constant of proportionality comparing feet to inches is 12. Lynn says that it is 1 over 12. Do you agree with either of them and explain why? So if there's 12 inches in 1 foot, one person says that the constant is 12, the other says it's 1 over 12. Do you agree with one of them, neither of them, both of them? What do you think? Make sure you're also trying to explain why. And I hope at this point we're not playing follow the leader. Don't be pressured to say something because you see a bunch of other things on the screen. I'm not saying these answers are incorrect. Not sure what that typo is there. Okay, I really like some of the answers that you're saying. I agree with Lynn because 1/12 would be dividing, and the problem is dividing 12 down to 1. Someone's pointing out that it technically could be either multiplying by 12 or 1/12. Okay, so we're in this conversation of it could be one or the other. What it comes down to is paying attention to the language of the problem. So if I'm comparing feet to inches, that means take the number of feet divided by the number of inches. So you have to pay attention to that language there. So if it's 1 foot by 12 inches, then that constant of proportionality is 1/12. If it said inches to feet, then you're taking the inches divided by the feet. So we're looking at these tables where both of them could work, but it all comes down to how the question is worded. So in this situation, if we're comparing feet to inches, we have to make sure we're doing that 1 over 12. So those of you that are agreeing with Lynn, I really like your answers and I really like your explanations. Again, because you have to pay attention to how it is worded. If it said, what is the constant of proportionality from inches to feet, then you would go ahead and multiply. Okay, so finish up adding in anything else you want to add onto that slide. All that you have to work on today is an Edpuzzle. No practice problems, nothing else. Easy Friday, watch the video, answer the questions. Once you're done with that, you're done for the day. So you can wait and hold off and do that 9th period, come in for questions. You can do it now, but that is the only thing that you have to worry about for the rest of the day is watch that Edpuzzle, get that turned in, and you're going to be good to go. So once you're done adding in any responses here, you are free to begin that. Again, if you want to take a break, wait till 9th period. That is also perfectly fine. Some of your answers make me giggle on here. See ya, Parker.